Hi, welcome to the demonstration video for binary classifier linear support vector machine or linear SVM project 1. So let's begin. So first we look at the project structure, and we have dependencies, program.cs, sentiment input data, and sentiment prediction output.cs class files. And we are using the same Yelp label.csv training dataset. So most of the program remains exactly the same as in previous chapters. So first thing we look at is the dependencies, and we can see that the Microsoft.ml we have version 1.1.0 installed, but we have already said that the latest version is 1.2.0. So let's update this by selecting the manage NuGet packages here. We go to browse and type ML for machine learning. And we see Microsoft ML here, and you have seen this before, so version 1.2. And so we just click update and click OK, and the new version should be installed. Let's check to make sure that we have version 1.2, and yes, we do. So let's move on to program.cs and make sure that you have imported Yelp_label.csv training file as part of your solution. And you also have to create sentiment input data.cs and sentiment prediction output.cs two class files. And you have seen this before in the earlier chapters, so I'm not going to spend too much time over here by repeating the same content. But it also shows the consistency of Microsoft.ml programming. So in this case, we go straight to program.cs. In this case, you can see that you have to import using system.io, and the Microsoft.ml libraries, Microsoft.ml, ml.data, ml.trainers, and ml.transforms. Then you import using static Microsoft.ml data operations catalog. So in class program, in step 1, of course, you declare two paths. One is training data path, one is model path, and you have done this before, so I'm not going to spend too much time here. Then we have classify sentiment as part of main method, and we have the details of the classify sentiment here. Again, similar to previous chapters, you have ML context as new ML context. Then step 3, iDataView, training data view, ML context data load from text file. We have sentiment input data, and we have the training data path, hazard or false, separated character, comma. Step 4, we split the training data set into 80% for training and 20% for evaluation. And so we have train test data, ML context data, train test split, and we pass the training data view and test fraction 0.2. In step 5, we create the data preparation pipeline. We have ML context, transform text, featureize text. Output column name is going to be features. Input column name is going to be name of sentiment input data.sentiment text. That's what the input sentiment text data is being passed to the featureize text method. Step 6, we create the linear SVM trainer. We use the data preparation pipeline.append method, pass ML context binary classification.trainers.linear SVM. And we pass label column name label and feature column name feature. So again, it's fairly straightforward, similar to the previous chapters. We create var model linear SVM trainer.fit train test data.train set. So we are going to use the 80% training data for training the machine learning model in step 6. Step 7, we create a iDataView object called predictions for evaluation data view. We use model.transform and pass the train test data.test set here. Step 8, we create the metrics ML context.binary classification.evaluate non-calibrated. When we pass predictions for evaluation data view, label column name label, score column name score, and predicted label column name predicted label. So these are the arguments that are passed to evaluate non-calibrated method of the binary classification class. And then we go to step 9, and we write some statements to get the matrix values to the output. So here we have accuracy, F1 score, area under ROC curve, precision recall curve. This specific algorithm does not have log loss or log loss reduction matrix, so we skip those two. Then we have confusion matrix, positive precision, positive recall, negative precision, and negative recall. And that's the end of the model quality, as you have seen before. We use in step 10, we declare and create sample sentiment text. I love this restaurant. You can use a different sentence to test your model right here. And then we create in step 11 prediction function, ml context.model.create prediction engine. We pass sentiment input data and sentiment prediction output, and then we have the model passed as an argument. Then we have step 12, use prediction function to predict the sentiment. So prediction result is equal to essentiated as prediction function dot predict, and we pass sample sentiment text that we created here in step 10. So it's very similar to what you have done in the previous chapters. Again, we send some output to the console and prediction result of sentiment text. We want to see the sentiment text we are classifying. We use convert dot to boolean, prediction result dot prediction, and positive negative. We want the conversion of the 1 for positive and 0 for negative. And then we have prediction result probability. And last part, you have seen before, we want to save the trained machine learning model for later use. We create a file stream object. We pass model path, file mode.create, file access.write, file share.write. And then we use ml context.model.save, pass model, training data view.schema, and file stream object. So that brings us to the end of the program here. Again, it's very similar to the previous chapters and very consistent. So let's run the program and see the output. So the output is here: binary classification trainer, linear SVM, model quality accuracy 63%, F1 score 27%, area under ROC curve is 85, precision recall 83, and the precision recall table is fairly good for the positive. The recall is fairly good for negative, so there is a bit of a discrepancy here, but the overall positive precision is 1, recall is about 0.16, negative precision is about 0.61. So you can see that the metrics here compared to the previous other algorithms we have seen on the same data set, this one is fairly low. Therefore, it may not be a good algorithm for this specific data set. Again, the point is that you try different algorithms on your data set to find the best algorithm that you want to train for your machine learning model. Thanks so much for watching.